Welcome to Chapter 4. Let me bring my mic over so you can hear me better. Welcome to Chapter 4, C Program Control. We're going to go through, in this video, 4.1 to 4.3. And basically, we're just going to talk about iterations. We've been speaking about iterations a lot. Our conversations have revolved around iterations and decision structures for the past couple of videos, but it's very important that you have a full grasp on what these actually do and how they operate. So let's jump into it. So in this chapter, we're going to talk about all this stuff. Next. I don't want to talk about the stuff that we're going to talk about. I just want to talk about it without having to go over it. So, a loop is great, loops are great. A loop is a group of instructions the computer executes repeatedly while some loop continuation condition remains true, which is your sentinel value. So, whether it's a for loop, as we spoke about in previous videos, and we'll speak about more in the future, whether it's a while loop, which we've also spoken about, and do loops, or do while loops, these will continue until a continuation condition or a sentinel value has been reached. Now, we've discussed, as I said, two different types of iterations, counter-controlled and sentinel-controlled. Counter-controlled iterations are like for loops. They run until the counter reaches a specific number. Sentinel-controlled loops run until a value that the sentinel or a sentinel value is reached. So if we look at our code that we wrote last chapter, you'll see that in this do while loop here, in the processing phase, we have a sentinel value here called counter. And what we're looking for, what we want the loop to realize, is when counter is less than 10, then I want you to stop doing the loop. There was also a time, if you go back and watch the videos, where I had another sentinel in here, and it wasn't, and it was input is not equal to -1. Now, the reason why I had that in there is so that the user can end the loop whenever they want it, and I can show you how that works. And I'll put this back because I already have a break in the condition. Or break in the... I already have a break in the code here. So when the value -1 is reached, this break will occur. So let's go ahead and put the break. Let's go ahead and test. It's running still. And there we go. Alright, it asks me to enter a grade, as it should. See the do. Please enter the grade. And then it's going to check the scan_s is checking to see what I add. So I'm going to put -1 in here. And look what I got. It gave me back no grades were entered. And that's exactly what it should have done. Now, what happened? Well, let's do a couple of things here. Let's make some breakpoints so you can kind of see what happened. If, print, else if, else, that. Okay, so I put a couple breakpoints in there because I want the code to pause at certain points because I want you to see what's happening. So, let's do our local Windows debugger, and bada bing, bada boom, we're in. Let's put in -1. -1. Boom. Automatically, we get to this if statement in the do while. So, it's checking to see if input is -1. It is -1. You can see that there, right? I'm scrolling over input. It's telling me what the value of input is. In debug, it'll do that. It'll tell you what's going on in the code at that specific point in time. So, input's -1. Well, this if statement says if input is less than -1, if input is not equal to -1, do what this body says, but it is equal to -1. So this is going to skip the body, or at least it should. Continue. So it went to the else branch because that's what was left. If it is equal to -1, the else is going to fire. So guess what happens? This break is going to execute. Now what should happen is at this break, this loop should stop looping. The break should make the loop, should break the loop and get us to the next part of the program. So, boom. And here we are. Now we're at... Okay. So, now we're at our next if-else branch. Or if-else-if-else branch. Now, what's going to happen here? Well, it's going to check to see if a couple of things have values. First of all, it wants to check to see if counter is not equal to 0. Well, counter is equal to 0. So, this is automatically going to be false. Why? Because counter cannot be equal to 0, and the grades must be greater or less than 8. Grades is 0, counter is 0, but it always looks at the first one, and if that one's not true, in an AND, with this AND operator here, it's just going to say it's false. It's not even going to read the next part. So what should happen is, it should skip this printf and go straight to else if. You see how it didn't even go to the next breakpoint? I put that breakpoint there on purpose. Because if the code went into the body, this breakpoint would have fired. But it didn't even go into the body because counter is equal to 0. And this says if counter is not equal to 0, run the body. So it said, you know what, counter is equal to 0, let's just go to the next one. So it's going to check to see if grades is less than or equal to 8. Well, grades is less than or equal to 8. So let's see what happens. It skips it. Or I'm sorry, if grades are greater than or equal to 8. I read that wrong. I apologize. So grades are not greater than or equal to 8. Grades equal 0. So this also will not fire. So this else if just skips the body, goes to the else. The else doesn't have a Boolean condition. So what this literally means, everything else goes into this one. And everything else is you didn't enter any grades, basically. So this should fire. And if I open up the program, there you go. No grades were entered. And that's how it works. That's exactly how it works, looking at it on the back end. This is basically how the program is looking at it and going through it one by one. So you're getting a bird's eye view of what's happening behind the scenes. So let's go ahead and get rid of all these breakpoints. And there's probably a button in Visual Studio that lets me do it without clicking them all one by one, but I don't know what it is. So there you go. I was talking through it to make it sound, make it seem not like it didn't take that long. All right, so counter-controlled iteration is sometimes called definite iteration. Sentinel-controlled iteration is sometimes called indefinite iteration. And the reason why that is because counter-controlled iteration will stop at some point. At some point, it has to stop because there's a number that's associated with how many iterations it should have. Whereas a sentinel-controlled iteration is sometimes called an indefinite iteration because there is no real stopping point there. So, in counter-controlled iteration, a control variable is used like I. So let's go over this really fast so I don't have to read this to you and bore you to tears. So, if you remember from the last couple of videos that I've done, I really tried to make this into a for loop. I really didn't want to use a do while. I wanted to use a for loop. And the reason why is because I just like for loops. So let's write a for loop here. For int I equals 0. That's the first parameter. There are 3 parameters in for loops. There's the initialization of the index. There's the controlled sentinel. And then there's the index or the index increment or decrement. So right now we just what we did was we initialized the variable I and we gave it the assignment 0. This could be anything. You can name this index, you can name this your name, you can name this anything you want to name it, but I is normally what we name it. So I. You can name it J, you can name it K, you can name it L. If you have multiple loops, it's preferred that you do that, especially if you're trying to use the index in the loops, but in this case I'm just going to go with the tried and true I. Because it's just a variable, really. So index or int I equals 0, and we'll say while I is less than size of, and size of detects how big something is. And normally when you do a for loop, you do it based on like an array. An array has a subset of information or a subset of values in it, and you want to iterate through those values. And so I don't have an array, but I'll just say input. It's going to error out because input's not. Well, I guess it won't, but that's not true. Input's integer, so it's going to go look at the integer and it's only going to do it once. And then I++. Now we spoke about this at the last video as well. I++ really equals I plus 1. And that's how you write a for loop. And then inside the body, you'll write stuff. Now, what's important about this? Well, in a for loop, what you want to do is you want to, and we spoke about this in the last chapter, I'll go over it in a little bit of detail. Each position in an array, or each element has a position in the array, with the position starting at 0. So there's the 0th position, the 1st position, the 2nd position, and the 3rd position. What the index does is it tells us what position that we are in, depending upon where we are in the array. So if I wanted to do something like printf, right? Printf, and then inside here I said the array position value is, right? And I said the value is I don't know. We'll make it numbers, and then I'll make a. Hopefully I don't blow this up. I'll make a int array. I'm gonna try to make an int array. Let's see if I can get this right, because I don't remember the syntax for making arrays in C. There we go. Got it. So we have an int array, and then we'll do our curly brackets. We'll say 1,000, 100, 10. All right. I could have also did this without the number there. So I'll do it without the number. And what we'll do is we'll say the array position value is, and then I will say I want you to use array I. Boom. And then I'm going to comment out the rest of this because I really don't want this to fire while I'm running this. So boom. And boom. I want my array though in my for loop, so we'll bring that back. All right. So I have an array. I actually can get rid of this too. So there we go. So I have my array, and actually I'll bring this down so it's easily readable. So I have my array. Okay. Not input, it's array. So I have my array, and I have my array. I have a for loop. So let's do some breakpoints and let's see what happens, shall we? Get rid of that. All right, boom. Let's run this. No whammy, no whammy, no whammy. All right. So what it first did was it tried to initialize our array, and our array now has values in it, as you can see. They're interesting values, but they're values nonetheless. And they're sitting in memory locations that you can see there, or the memory location you can see there. And if I pull this down, you can see that each of these locations have a specific array value, which is fine. Go to the next one. All right, so now you can see I'm scrolling over the array. You can now see that the array has 1,110 as values inside of it, and the memory location that that's being stored at. Now, what happened here? Well, size of array pretty much tells us how many elements are in the array. And size of says that there's 3 elements in the array. You don't see it, but it does. Okay? And as long as I is less than 3, this is going to run 3 times. Or it's going to run until I is greater than or equal to 3. As you can see, I is equal to 0, and I++ does what it's supposed to do when it's supposed to do it. Obviously, it didn't increment yet. It will increment after the iteration. If I had put these pluses before the I, it would increment before the iteration, and I just don't want that. So, printf, I want to print the stuff that's here, okay? What is array I? What is this value? Well, this value is whatever the index number is, okay, because we're indexing the array right now. So whatever the number of I, or whatever the value of I is the position in the array. So if I equals 0, which actually I does equal 0 right now, what's going to be here in place of I is a 0. So what this basically says is array index of position 0. Well, what's in the 0th position in the array? 1,000. It's the first thing that's in the array. That's the 0th position, the first value. So what should print here? 1,000. I'm telling it give me the value of I indexed at the array's position. So I know I'm saying that sounds confusing. I'm trying to say it that way for a reason. Now I'm going to say it in layman's terms. Give me the 0th position of the array. That's what this means, right? Give me the position of the array which I denotes. Right now I is 0, so this really says, technically this really says I equals 0, okay? But we have I there because we want to make this dynamic. So if I press continue, it's going to run the loop again. It just ran the loop again, so I equals 1. But let's go here. The array position value is 1,000, so we got the right value. So let's look at the second part of this. Okay, so it iterated again. I is equal to 1. Is I still less than 3? Because there's 3 values in the array, and size of tells us that there's 3 values. It's telling us that. So this is 3, number 3. Okay? So I, or 1, is less than 3. That's true. So we're going to keep running the loop. Right now, the array has the value of 1. So what should print in this printf? 100. Because 100 is in the first position. This is the 0th position. This is the first position. Let's see what happens. All right, we have 100, and I'm now kicking myself for not putting a breakpoint there, but it doesn't matter. So now the array position value is 100. Okay, so now what it is? Now what's going on? Well, now we are at index of 2. We have I2, or I, they're the same thing, they're synonymous, is less than 3? Yes? Okay, run the array again. Well, what's going to happen? I should get the value in the second position. This is the second position. So this is the 0th position, the first position, second position. So technically what should print in this %d area is 10. Does that happen? Yes, it does. 10. Now it's going to run one more time because obviously something is not right. Maybe size up gives me everything in the array, and I don't want that. I just wanted the length, but ignore that. I'm going to figure out what the length's supposed to be, but either way, it did what it was supposed to do. Alright, onwards. Sentinel values are used to control iteration when the precise number of iterations isn't known in advance and the loop includes statements. This first part's not necessarily true because the way I developed that for loop, we didn't know how many things would be in the array in advance. I just said however big the array is, give me all the elements in the array until the length is reached. So, the loop includes statements that obtain data each time the loop is performed. That is true. The sentinel value indicates end of data. That is true. The sentinel is entered after all regular data items had been supplied to the program. Let me keep going. Some of this is like conjecture, so I don't read it because in the real world, that's not really the way it works. This is somewhat true, but counter-controlled iteration requires the name of the control variable. I is what I use for the control variable. The initial value of the control variable, I initialize I to 0. The increment or decrement by which the control variable is modified, we incremented I ++ by 1. The condition that tests for the final value, and we asked for the size of the array. All of these are true. Consider the simple program, unsigned int counter equals 1. So this is the initialization phase where we're initializing our variables. This definition is not an executable statement. While counter is less than or equal to 10, printf, and then increment counter first, which is fine in this case. But it also means, no, that's fine, yeah. The definition and initialization of counter could also have been written as unsigned int counter and then counter equals 1. But this is kind of like redundant. We don't have to do this. We can just say unsigned int counter equals 1 and have it all on one line. This increments the loop counter by 1 each time the loop is performed. It increments the counter by 1 before the statement which the counter exists in, the expression where the counter exists, executes. That is very important. Counter ++ or the post increment increments after the expression or the programming statement has been executed. In this case, counter is the only thing on that line, so it doesn't matter if you put it in the beginning or the end. But if counter was in an expression or in a programming statement with other things, this would change the value of counter and the value of the end value of the algorithm. The loop continuation condition in the while statement tests whether the value of the control variable is less than or equal to, The loop terminates when the control variable, so this is something that we did in our actual, and I apologize for saying I'm just reading it and we've already gone over most of this, so I don't want to bore you to tears on being redundant, even though it is extremely important that I am extremely redundant so that you hear it more than once, because the human mind does not remember or make habits until at least the 7th iteration of a specific thing. So, with that being said, I will reiterate myself over and over again until it makes sense. But in this case, we have a do while loop here, and a sentinel counter is less than 10, and as you saw, a break. I can run this 10 times, and then it will stop. This is what we call our sentinel value, which has been reached, and a breakpoint. So, you can make the program while ++ counter is less than or equal to 10, but I don't know, I don't like this too much. I mean, yeah, if you want to be succinct, but I like to keep the counter outside of the sentinel loop because sometimes you want to define when the counter is incremented. Sometimes you don't want the counter to increment in your code, so this might not necessarily be the best of choices, but you could do it if you want. This is actually not bad code, to be honest. And yes, I am one of those programmers who feels that this makes the code too cryptic and error prone. I do. I feel that this should be in the body of the while loop, so you can actually see it operating, and there's no chance of logic errors occurring. This can create logic errors, and those are the worst. Remember what logic errors are. 2 types of errors: syntax, logic. Syntax prevents the code from compiling. Logic only fires during runtime, and there are many logic errors that are not caught by the program. You don't want logic errors at all. So try to avoid things like this. This can create a situation where you get errors that you just can't track or well, yeah, you can't debug. So Floating point values may be approximate, so controlling counting loops with floating point values may result in imprecise. This is a very true statement. Only use integers for your counters. Don't use floating point, please. Yeah, control counting loops with integer values. Most loops are counting, so just use integers. Too many levels of nesting can make a program difficult to understand. As a rule, try to avoid using more than 3 levels of nesting. Here's the real rule. Try not to nest. Don't nest at all. If you have to nest, refactor your code. Go back and find out why you have to nest. Try to avoid nesting at all costs. This is not the only problem that arises with nesting. In some situations, nesting can cause the program not to run correctly. Just try to avoid nesting at all costs. The combination of vertical spacing before and after control statements and indentation of the bodies of control statements within the control statement headers gives programs a two-dimensional appearance that greatly improves program readability. True. And we are finished. I'm going to stop at 4.4 and start a new video. If this has been helpful, let me know. Otherwise, I look forward to hearing your responses and seeing your work. It's been fun, and like I always say, ciao.